Hello everyone. In this video, we look at the graph analysis or graphical analysis kind of scenarios with regard to the motion in one dimension. Now, generally, right, graph-based analysis can be with regard to uniform acceleration motion, or it can be uniform retardation, or we can even have graph analysis questions where we'll have non-uniform acceleration. So it is not like graphical analysis means we'll have only one type of motion. It can be applied for any, it can be applied for the uniform acceleration or uniform retardation type of motion. Even we can talk about the graphical analysis for uniform velocity motion. Even we can talk about the graphical analysis for an object which is at rest also. Okay. So we'll see, what are the different scenarios we can have in terms of the graphical analysis, but this is not limited to one particular type of motion. This can be done for any type of motion. Okay, before we get into the graph analysis, let us talk about this idea of slope of a straight line. This is something that we are used to in the general mathematics. Like when you have a straight line, we're talking about the straight line which is in a 2D plane, like the way we have a straight line which is in the XY plane. The straight line, if it is making an angle theta with the positive direction of the x-axis, so we can see we can call it as case A, case B, case C. In case A, the straight line is horizontal, means it is like making an angle of 0. The angle made with the positive x-axis is what? 0. So the slope of the straight line will be given by tan of that angle. So you can see here tan 0 means what? It will be 0. So for a horizontal line, the slope will be what? 0. Whereas if you have a vertical line, right, what will be the slope of the vertical line? So vertical line means it will be making an angle of 90, right? If you take a vertical line means it will be making an angle of 90. So we can just draw the vertical line here. If you draw a vertical line means we have to assume that with the positive direction of the x-axis, it is making an angle 90, right? So tan 90 will be what? Infinity. So for the vertical line, we will have to take the slope to be what? Infinity. But general normal straight lines, if we consider other than the horizontal and vertical, what do we see? We will see either the straight line making an acute angle. In that case, tan theta will be positive, right? In the first quadrant, tan theta is what? Positive. So if it is making an acute angle means the straight line will have a positive slope. If it is making an obtuse angle, like you can see, this is the straight line here. If it is making an obtuse angle, here theta will be what? More than 90. Then tan theta will be, in second quadrant, tan theta is what? Negative. So slope of this straight line will be negative. So when you talk about the slope of a straight line, it can be 0 if it is a horizontal line. It can be infinity if it is a vertical line. If the line is making an acute angle with the positive x-axis direction, then it will be having a positive slope. If the line is making an obtuse angle with the positive x-axis direction, it will be having a negative slope. Okay, so this is how we can have the various possibilities for the slope of a straight line. We will see what is the significance of this. Okay, if you look at any curve, okay, it may be whatever the shape of the curve. Okay, so let us say we are talking about a curve here. Okay, so this is a curve. What is a chord? There are two important straight lines in relation to a curve. One is a chord, other will be the tangent. So chord will be the line that is connecting 2 points on that curve. That is what we call as a chord. What is a chord? It is the line that is connecting 2 points on that curve. Now if you look at the slope of, let's say we are marking the this is the graph of y with respect to x. So y is depending upon x. Okay, so in this we can mark the coordinates of the points. Let us call it as a first point, call it as second point. First point coordinates can be x1 comma y1. Second point coordinates can be what? x2 comma y2. Okay, now slope of a straight line, right, we have not talked about it before, but the slope of a straight line, even we can just look at it. We have a 2-point formula. So if you consider this right angle triangle. Let us call it as, x2 comma y2, these are the coordinates, and this is the x1 comma y1. Then the height of the right angle triangle you see here, right, that is what, y2 minus y1, and the base will be what, x2 minus x1. So this is theta here. So tan theta will be equal to what, y2 minus y1 by x2 minus x1. So this is what we call as the 2-point formula for getting the slope of a straight line. What is it? y2 minus y1 by x2 minus x1. Now by the same relation, right, we have the chord which is connecting the 2 points x1 comma y1 and x2 comma y2 on that particular curve. So what will be the slope of the chord? We can see what is slope of the chord. Slope of the chord will be equal to what, y2 minus y1 by x2 minus x1, right? So that is what we can write as a delta y by delta x. So what is this delta x? Delta y is what, change in y, divided by delta x is what, change in x. So this is what we can say the change in y with respect to change in x. So we can also call it as rate of change of y with respect to x. So how do you measure it? Change in y value, delta y, divided by change in x value. That is how we will call the rate of change of y with respect to x. Okay. So this is what is the significance of the slope of a chord. When you take a chord to a curve connecting 2 points, the slope of the chord will be giving us what, the rate of change of y with respect to x. Okay. Now we will go to the tangent concept. What is the tangent? So we'll try to understand the tangent concept by using the chord. So how we'll try to relate the chord concept to tangent? See here, when we talk about a chord, right, so we are talking about 2 points, point 1 and point 2. The line that is connecting them is what we called as a chord. Now if you so the separation between them is what, the separation between these 2 points is what we are calling as the delta x. If you make this delta x to be very, very small, how small? This is approaching to 0. Okay. So if you make the value of the delta x to be very, very small, so that it is approaching to 0, then what would happen is these 2 points will approach each other. So if the separation between the 2 points is almost becoming 0, means what, the 2 points will approach each other. So they will approach onto one particular location on the curve. That point, if you look at the straight line, right, the straight line, it will be like what, touching the curve at that particular point. So this is what we can call as point P. So if you take the chord and make the 2 points of the chord to approach each other, so mathematically what we'll say is the delta y by delta x, that is the slope of the chord. So we will have to make the delta x to approach to 0. So that has to become very, very small. So in mathematical language we will call it as what, the limiting principle. Limit delta x approaching to 0, or we can say tending to 0. Okay, all these things we will have to look at in the basic math. So limit the delta x value tending to 0 or approaching to 0. This delta y by delta x, right, this we will be representing. So here when delta x is becoming almost close to 0, right, delta y also will almost be becoming 0. So we will use a different notation, that is what we call as the differential element notation. So here dy will be what, this is what we call as the differential change in y, very small change, and dx will be called as what, the differential change in x. So dy will be the differential change in y and dx will be the differential change in x. So this is what will be given by the slope of the tangent. So whenever we draw a tangent, tangent means what, the line that basically touches the curve at a single point. When you draw a tangent, the slope of the tangent will give us what, the rate of change of y with respect to x at a given point. Okay, so this is also what we will be referring to as the instantaneous rate of change of y with respect to x. So we can see clearly where these things are going to be used. So we talked about what is the slope of the chord and what is the slope of the tangent. So slope of the chord gives us what? The average rate of change of y with respect to x. Okay. And the slope of the tangent will give us what is the instantaneous rate of change of y with respect to x. That is represented by the differential change in the value of y dy divided by the differential change in the value of x, that is dx. Now the other thing that we look at in terms of the graphical analysis is the area between the curve and the x-axis. So we'll see what is the significance of this area. Let us say we have a curve like this. Okay, so this is a variable y which is depending upon x. Now what are we talking about? Area between the curve and the x-axis. So let us just mark it. If you take 2 points, x1 is 1 point, x2 is another point. We are talking about area between the curve and the x-axis, between these two limits. So what is the significance of this area? The significance of this area will be, if you try to understand this in terms of the integral relation, look at this. At a particular point, we take a very small change in the x, that is what we call as the differential change in x, that is dx. Mark the corresponding y value. If you do y into dx, what is it? That is like the area of that small rectangle you are forming. So it's like what? Having a spread of dx and height is what? Y. That is the area of the rectangle. If you try to add up all these rectangles, so mathematically what we will have to say? We will have to say that we have to integrate it. If you add up all these, we have to integrate it between the limits x1 to x2. That integration is going to give us what? The area between the curve and the x-axis. So what is the significance of this area between the curve and the x-axis? It is nothing but what? The integration of y dx. So y is the parameter or the function we have that is marked on the y coordinate, and x is the variable. Okay, so the integration value will be giving us what? It will be giving us the area between the curve and the x-axis. So here we will have one more thing that we need to consider. The area, right? As we have seen here, the curve is completely above the x-axis. Sometimes what can happen is the curve can be coming below the x-axis. Sometimes what can happen? The curve can be coming below the x-axis. In that case, what is the significance of that? Let's say we have a curve. A part of the curve is above and part of the curve is below. Wherever the curve is below the x-axis, right? The significance of that is this particular area. So when you measure the y coordinate here, right, it will be what? Negative. So accordingly, the area here will be coming as what? Area is going to be coming as negative. So whenever we have the area below the curve, right, that area we have to take it as negative. Why it will be negative? Because since the y coordinate here is negative, right, when you complete the integration, so in this integration, so for example here this is our x1, this is our x2. From here to here we are integrating. Integrate it x1 to x2 y. This is a negative quantity. Okay, this is a negative quantity dx. So that the overall value will be coming as what? Negative. So whenever we have the curve below the x-axis, the integration value for that will be coming negative. So that area, right, we'll have to consider it as what? Negative area. Above the x-axis means positive area. Below the x-axis means we have to take it as what? Negative area. So this is about the significance of area between the curve and the x-axis. Now we will see what are these common graphs that we will be talking in terms of the one dimension motion or kinematics in general. Okay, so we'll talk about the displacement time or position time. I think in one of the previous videos also we have said what is the relation between them. The relation is very simple. Displacement means it will be what? X minus x naught. X is the position at a given time, x naught is the position at the starting time. That is the basic difference. Okay, so we can have the position time graph, or we can have velocity time graph, or we can have acceleration time graph, or we can be having what? Velocity versus position. these are independent of the time. Or we can have acceleration versus position, how acceleration is changing with respect to position, like that. Okay, but the most common ones are the graphs related to the time, because the meaningful analysis, right, like what we are talking about, can be done by using these graphs which are dependent upon time as the variable. Okay, so first we'll begin with the position time graph. Let's say we have a position time graph. Okay, so means talking about 1D motion, right, assuming that the particle is going along the x-axis, then the position is given by what? The position is given by the x coordinate of the particle, correct? So here what we can see is that the position of the particle can be represented by the x coordinate value for the particle. Okay, so we have the x coordinate versus time, that is the graph. Now this graph is given to us. If you mark 2 points and you form a chord, the slope of the chord, right, what is the slope of the chord? Just now only we discussed about it, right? What is the slope of the chord? It is delta x by delta t. What is this? The overall change in position by the time taken. What is it? This is giving us the average velocity. The overall change in position by the time taken is what? It will be the average velocity. Okay, instead at a particular point we draw a tangent to the curve. Let's say at this point we are drawing a tangent. The slope of the tangent, right, what is the significance of slope of the tangent? That is like our dy by dx, right? In this case, what is it going to be? Dx by dt, because there in the usual graph means what? Y coordinate and x coordinate. So here it will be what? On the y axis we are plotting the position. Okay, don't think that this x and this x are same like that. Okay, so that is generally, we'll have the x coordinate and y coordinate, right? But particularly here the y coordinate is what? The position function, and the x coordinate will be, because in most of the times, like I said, right, we'll analyze the graphs involving time. Okay, so the slope of tangent will be what? Dx by dt. What is this? This is the instantaneous velocity. So when you have the position time graph given to us, position time, or even the displacement time given to us, the slope of the chord will give us the average velocity, and slope of the tangent will give us the instantaneous velocity at a given time. Okay, so that is about the first graph. That is over. Now we will go to the second one. What is second one? The velocity time graph. Okay, so velocity time graph, if you have velocity time graph, right, first time graph, same. So we have the curve over here. So we have the curve. If you take 2 points and you try to take the slope of the chord, so slope of the chord, it will be giving us what? Delta v by delta t. That is the average acceleration. Similarly, if you draw a tangent, we draw a tangent, then slope of tangent, right, to the curve taken at a point will be what? It will be dv by dt. That is our instantaneous acceleration. That will be what? That will be the instantaneous acceleration. So for the velocity time graph, when we are talking in terms of the slope of a chord, that will give us the average acceleration. Slope of a tangent means it will give us what? The instantaneous acceleration. So for the velocity time graph, we also have one more analysis possible, that is the area based analysis. So look at this, we mark 2 time points, t1 and t2. If you look at what is the area between the velocity curve and the time axis, right? Here what is the x-axis means time axis only, no? So what is it? It is nothing but integral t1 to t2 v dt. What is this? This is nothing but the overall displacement, or we'll say overall change in position, correct? So whenever we take the area of the velocity time curve and the x-axis, that will be giving us what? The overall displacement. So here like I said in the analysis of the area, if for some part the curve is above and for some part the curve is below, so here the displacement, let us call it as S1, that will be what? Positive. Here the displacement S2 will be taken as what? Negative. So whatever the area value, right? Whatever the area value, when it is above means the displacement is that much value, that's it. But if the area is going below the x-axis means what? We have to take the displacement for the corresponding limits to be what? Negative. Okay. Whatever the area value, let's say the area is, in this case the area is coming as what? 2 meters. So the S2 value will be minus 2 meters, because as per the convention, right, whenever it is going below we have to take it as what? Negative. So this is about the area analysis on the velocity time graph. Next we have the acceleration time graph. So acceleration time graph, if you are taking a acceleration time graph and we are looking at what is the area that is enclosed between the acceleration time graph and the x-axis. In this case x-axis is what? All these are the graphs where we are having the variable as the time. So you look at it, what is the area? It is nothing but integral t1 to t2 a dt, right? That is the area in terms of the integral expression. So what is this? This is nothing but delta v, or the change in the velocity. So when you have the area between the acceleration curve and the time axis, right, that area will give us what? The overall change in the velocity, that is v final value minus v initial. Acceleration time graph slope, right? Slope will only tell us what is the rate of change of acceleration. Okay, slope will only tell us what is the rate of change of acceleration. Okay, we can have a slope of the chord means average rate of change of acceleration. Slope of the tangent we take means it will give us the instantaneous rate of change of acceleration. Okay, so this is about the graphical analysis in terms of position time graph, velocity time graph, and then acceleration time graph. Now the other graphs, right, we will not have exact analysis like this, but based upon the problem to problem, they might give us a scenario and then ask us to find out those quantities. Okay, so we'll see as we go on to solve some questions, right? If there are any graphs which are not involving time, let us see what kind of questions can be framed on that, and we'll have to work it out. But the major analysis will be on what? The position time graph, the velocity time graph, and then acceleration time graph. So we'll just try to summarize it. We have the displacement time, or we can say position time. Okay, x means we are assuming that the particle is moving along the x-axis. Okay, for this if you take the slope of tangent, that will give us what? Instantaneous velocity. Here area, we are not even talked about it, right, because area doesn't have any significance for the position time graph. Velocity time graph, you take a slope of the tangent, it gives us what? Instantaneous acceleration. You take the area between 2 points, it will give us what? The overall displacement. Now comes the acceleration time graph. Acceleration time graph, what we have seen, the slope will give us the rate of change of acceleration. This also does not have much significance. But what about the area for the acceleration time graph? Area between the acceleration curve and the x-axis is what? The overall change in the velocity, that is final velocity value minus initial velocity value. Okay, so this is about the common graphs and the analysis that we can do on the common graphs. Now we'll see what are some of the cases where the graphs we will say will not be possible. Like sometimes, you know, even we don't get questions like this in JEE advanced level, but at times they can just give off questions like this in the mains. Look at this, the graphs that are not possible. So we'll see some of the examples of the graphs where the graphs will not be possible for different reasons. We'll even talk about the reasons also. Look at this, we have a velocity time graph and displacement time graph. Here we are saying that both these graphs are not possible. Maybe you can just think for a while and tell me why these graphs will not be possible. So why these graphs will not be possible? Look at this now. If you have the velocity time graph, this is becoming like a vertical. It's like what? It is becoming like a vertical line. Here also the displacement time graph, it is becoming like what? It is becoming like a vertical line. Now when it is a vertical line means what is the slope of the vertical line? We have talked about it, right? Slope of the vertical line will be what? Infinity. So means if you say that this graph is possible, right, you are telling that acceleration is infinity, because slope of the velocity time graph is what? Acceleration. If you say that this graph is possible, then you are telling me that no, velocity is infinity. So can we have acceleration infinity, velocity infinity? Not possible, right? So that is the reason why if you have a velocity time graph, it cannot be vertical. If you have a position time graph or the displacement time graph, that also cannot be vertical. Why? Because if it is vertical means, velocity time graph vertical means what? We are saying that acceleration infinity, which is not possible, right? Position time graph is vertical means what? We are saying that the velocity is infinity. That is also not possible. Okay. Next, look at this set. This set also we are saying not possible. I'll tell you the reason why. Because for a particle which is moving along a straight line, if you mark a time t0, the velocity can either be v1 or v2, because we are talking about a single particle, right? For a single particle which is moving along a straight line, there will be only one velocity term. At a given time, there will be only one velocity term. So t0 means, see, it is moving. I say at t is equal to 2 seconds. What is the velocity? It will have only unique value. It cannot have two possible values. Look at this. If you draw a vertical line, it is cutting the curve at 2 points. Means for a given time, we are saying that two possible values of velocity will be existing. That is not possible, right? For a given time, you say t is equal to 2 seconds means this much velocity. T is equal to 4 seconds means this much velocity, like that. Okay, for a given time, velocity cannot have two possible values. Same in this case also. You see the right side one? For a given time, we are saying it can be in two positions. No, right? At a given time. So we'll ask like, t is equal to 3 seconds. At t is equal to 3 seconds, what is the displacement? Correct. So like that we will be asking, which means what? At a given time, the position of the particle will be unique. It cannot be in multiple places. At a given time, the particle cannot be existing in multiple places, which means the displacement also has to have unique values for a given time. That is the reason why these two graphs will not be acceptable. Okay. Now let us go to the next graphs. These graphs are also not possible. Why? We will see. These are what? Distance and speed graphs, which are going below the x axis. Means what? In distance time graph, can distance moved be negative? Distance cannot be negative, right? Distance covered is what? It is the length of the path taken by the particle. Displacement, as per the sign convention, sometimes can be coming negative, because if you take the right side, displacement to be positive, right? If the overall displacement is negative, means it will indicate that the particle is ending up on the left side. But distance is the length of the path covered, that cannot be negative. And moreover, look at it, no, the distance cannot decrease. As the motion is happening, distance has to always increase only, right? It is going to cover more and more path. So with respect to time, distance cannot be decreasing. So why we are saying this is not possible? One is the distance is going below the x-axis. Distance is the length of the path covered. It cannot become negative. That is one point. Second thing is they are showing us that the distance is decreasing with respect to time. Distance cannot decrease, right? Distance will be always increasing. Okay, so that is the reason why this will not be possible. Now look at the other one, right? We have the speed versus time. Again, same reason. It is going below the x-axis, because speed is what? We'll say at an instantaneous value, speed is what? It is the magnitude of the velocity, right? So speed cannot be negative, because magnitude of a vector will be always what? It will be always non-negative. It can be zero. but it will be always non-negative. So here we are showing, based on the graph, we are showing that speed is negative. So speed cannot be negative. So that is the reason why these graphs will not be possible. Okay. Now in our analysis, right, like we talked about mostly the position time, velocity time, and then acceleration time graphs. So we will talk about some particular cases. The particular cases that we analyze are, one is the case of rest, and maybe we can even call it as the case 0. Okay. Why? Because that's a very peculiar case. Okay. Then we'll have uniform velocity. Other one will be uniform acceleration. Third can be uniform retardation. Okay. Then the fourth one, because this motion of a particle in vertical straight line motion, right, that is another interesting situation. So we can have the graphical analysis of a particle which is thrown upwards. Okay. So for a particle thrown upwards, so this is an example for the motion under the gravity. Okay. So these are the 5 cases, including the case 0, which is the rest. So we will see how we will be able to analyze these things one by one. Okay. So first we will talk about the case of rest. So rest means what? Its position, whatever is the position, right, will remain constant. Means displacement will be 0. Displacement 0 means velocity is 0, and velocity is 0 always means acceleration will be what? 0. So we can see, if you try to plot acceleration with respect to time, means it will be 0. If you try to plot velocity with respect to time, that will be also, the line will be on the x-axis. If you try to plot position or displacement with respect to time, it will be, so if you try to plot velocity versus time, it will be what? On the x-axis. If you try to plot displacement versus time, it will be also what? On the x-axis. What about the position time? Whatever is the initial position, let us say it is having an initial position of x0, that is going to remain constant. Whatever is the initial position, that is going to remain constant. If the initial position is 0, origin, then that is going to remain constant. So whatever is the initial position, right, that is going to remain constant. So this is about the graphical representation of the situation of rest. That is what we are calling as the case 0. Okay. Now the next one is uniform velocity. Uniform velocity means what? The velocity will be constant. Okay. So velocity constant means acceleration will be 0. Velocity constant means what? Acceleration will be 0. Okay. So if you look at the acceleration time, it will be 0, right? So it will be on the, you can see, it will be on the x-axis. What about the velocity time? Velocity is constant, right? Which means what? It will be a line which is parallel to the x-axis. This is the constant value. Now what about the displacement? Because for a displacement time graph, the slope, right, slope is given by what? Slope will be given by the velocity. So if you look at this line, what is the slope of the line? You can see this is a line which is passing through the origin. So what is the slope of the line for a time t? If the overall displacement is s, what is the slope here? Slope will be what? S by t. So it's a constant velocity, right? So slope of that line will be what? It will be a constant. So the displacement time graph will be what? It will be a straight line. Say straight line means what? The slope of that, so wherever you draw the tangent, for a straight line, tangent means same straight line, right? Wherever we draw the tangent, the slope of the tangent is equal to slope of that straight line, which will be always remaining constant. Okay, so that is the displacement time graph for a uniform velocity motion. Now we will see for a uniform acceleration. Uniform acceleration means what? Acceleration will be constant. Uniform acceleration means acceleration will be constant. Okay, if the acceleration, when we will say acceleration, when in 1D motion, right, when the velocity and acceleration are in the same direction, we will say the body is getting accelerated. Correct. When the velocity and acceleration are in different directions, then we will say it is what? Retardation. So here if you talk about uniform acceleration means what? Acceleration will be a constant value. It will be like a straight line which is parallel to the x-axis. What about the velocity time graph? Because slope of the velocity time graph is what? Acceleration, right? So slope of the velocity time graph is what? Acceleration. So we'll have, since the slope has to be constant, slope of the tangent, wherever you draw the tangent to the velocity time curve, the slope of the tangent must be always a constant. So that graph will end up being what? It will end up being a straight line. So the velocity time graph will be straight line because the slope of the velocity time graph should be always a constant value, and that will be possible only when you have a straight line. So we see that there is a straight line, and a straight line will be given by what? The equation, right? What is the equation? V is equal to u plus at. The equation is what? V is equal to u plus at, right? What about the displacement? We know in case of uniform acceleration, what is the displacement equation? S is equal to ut plus half at square. So how about the curve shape? It will be, see, the displacement will be increasing, but the slope of this, right? What is the slope of the displacement time graph? It is the velocity. Since it is uniform acceleration, you see that slope of that tangent you draw, velocity will keep on increasing, right? So slope of the tangent you draw will keep on increasing. So the curve, in case of the acceleration motion, right, the curve will be, is a very standard thing, it will be concave upwards. We can see how it is, right? It will be like what? Concave upwards. The concave part is facing up. That is when the object is in acceleration. When it is in acceleration, uniform acceleration, the displacement time graph, right, it will be what? It will be concave up, because the slope of the displacement time graph, which is our velocity, that will keep on increasing. Okay, so here if you want to know what is the initial velocity, means what you will do at the t is equal to 0 point, you have to draw the tangent. If you draw a tangent t is equal to 0, means what we will get? The initial slope, which is our initial velocity u. Okay, but the curve is given by what? S is equal to ut plus half at square. Now we will see the case of uniform retardation. Means what? If the initial velocity is let us say u to the right, then the acceleration will be in the opposite direction. Okay, but it is uniform retardation, means it will be negative. You can see this is the x-axis, right? What is this? This is the x-axis. So we are keeping our acceleration below the x-axis. Where we are keeping the acceleration is kept below the x-axis. We can see it will be what? Below the x-axis. So it is a negative acceleration. What is the significance of negative? Because that is what we do in 1D motion, right? If the initial velocity direction we take positive, means the acceleration which is in opposite direction will have to be taken as what? Negative. Correct. So this is about the constant but negative value for the acceleration. That is what is our uniform retardation. What about the velocity time graph? Because here velocity will keep on decreasing, right? But the slope of the velocity time graph, it should be what? The slope of the velocity time graph should be constant. It will be negative, but it will be what? Constant. When is it possible? When we have a straight line. Correct. So look at it, this is what is our straight line. So if you start from the initial velocity u, it will be a straight line. Okay, so what will be the equation? Let's say we'll have v is equal to what? U minus at, because the acceleration will be negative acceleration, right? Okay, so finally, you know, at some point of time the velocity will become 0. Okay, so that is the time where the object will come to momentary rest. Okay, so it will be a straight line with a negative slope. What about the displacement time graph? Because the displacement time graph, right, since there is a velocity, as long as there is a velocity, the displacement keeps increasing. The displacement value keeps increasing. But if you take the slope of the tangent to it, right, the slope of the tangent represents what? Velocity, right? You can see the velocity value keeps on decreasing. At some point it becomes 0. This is the point. Okay, and then, you know, the particles start moving in the opposite direction. That is how the curve will propagate. Okay, but here the thing is, we'll have to look at the shape of the curve. What is the shape of the curve? We can see in case of uniform acceleration, what we saw before, concave up. So here what do you see? It will be a concave downwards. So in case of uniform retardation, what do we see? It will be what? Concave downwards. So whenever you see these shapes, right, we'll be able to conclude. Okay, so whether it is a case of, if you have the position time graph or the displacement time graph, concave up means what? That is a uniform acceleration. Like this concave down means it is what? Uniform retardation. So this is how we will be able to analyze the case of uniform retardation. Now we will go into the fourth case, that is we have a body which is projected vertically upwards. So look at it, if you project a body vertically up with a velocity. Remember, in the entire journey, the acceleration of the particle is what? Acceleration due to gravity, which is g downwards. So we can see it like what? It is the case of the uniform retardation, because as the particle is going up, right, it is got a velocity of g downwards. It goes up till its velocity becomes 0, and then it starts coming in the opposite direction. So we'll see how the graph will look like. So what about the acceleration time graph? It will be what? G is 9.8, approximately 9.8 meter per second square, right? But we take it as what? Negative. So G will be what? Minus 9.8 meter per second square. Why are you putting minus? Because our sign convention upward we take positive, means down will be negative. That is about the acceleration time graph. What about the velocity time graph? We see starting from the point where we are projecting it, the velocity, it's a what is it? It's a uniform retardation, right? It's a uniform retardation, means it's a negative acceleration but constant value. So the velocity time graph, if you draw a tangent, means the slope should always remain same, which means what? The velocity time graph itself will be like a straight line but with a negative slope. Look at this. This is how the straight line is going to be. It will come to a point A. So if you're starting from O, point A is where the velocity becomes 0, that is the maximum height point. Then it will start coming in the opposite direction. So the velocity will increase but with a negative value. Overall in the entire journey, right, slope of the velocity time graph is what? The acceleration value. That will be always constant. You can see it will be a single straight line. Okay, it will be a single straight line, and by the time it is coming back to the surface of Earth again, right, the velocity will be exactly same value, assuming the air resistance, all these things are not present. The velocity will be what? If you throw an object with, say for example, 20 meter per second up, by the time it comes down, it will be having the same velocity, 20 meter per second, but downwards. You can see the final velocity, if you throw it up with a velocity u, means we take the initial velocity as what? Plus u. Finally when it comes down, it will come down with the same velocity magnitude but direction opposite. That is why minus u. Okay, what about the displacement time? So this is what is the case of the uniform retardation, right, which means what? It will be concave down. You can see this is what? Concave downwards. Now we will be able to see something interesting. If you draw a tangent to that displacement time graph, you see initially if you draw tangent, what is the angle here? Acute angle. With the x-axis the line is making acute angle, means what? Here the slope is what? Positive. That is why the initial velocity. What is the slope of the tangent represents? For the displacement time graph, slope of tangent represents what? Velocity, right? So you can see here initial velocity is what? Plus. At the point A, that is our maximum height point. So the slope of the tangent you draw, what is it? It's a horizontal line, right? So horizontal line means, what is slope of the horizontal line? 0, correct? So there, we can see that the velocity at the highest point will be what? 0. The finally when it is returning to the surface again, that is the point B, the final point. If you draw a tangent there, you see here what is the angle it is making? It is making an obtuse angle. Obtuse angle means what? More than 90. So slope of the tangent will be what? Negative. That is why when it is coming down, the final velocity is what? You can see it is negative. Okay, So this way we will be able to analyze some of the common scenarios. One is the object at rest, then we have seen uniform velocity, then we have seen uniform acceleration, now we are seeing uniform retardation. So this is how we will be able to analyze the graphs and the different scenarios. Now what we will do is we will start looking at some sample questions. Okay, so once we go through some questions, then we will be able to understand really what is the expectation in terms of questions. Okay, so we'll start with this question. It's a straightforward question. The figure is showing the displacement of a particle which is going along the x-axis as a function of time. The acceleration of the particle is 0 in which region? So they are giving us 4 regions marked here. A is basically AB part, B is the BC part, C is the CD part, and D is the DE part. So 4 options are given. We have to conclude which of them will have the acceleration of the particle 0. Now when acceleration has to be 0, right, that means what? The velocity must be constant. Velocity constant means the displacement time graph should be what? It should be a straight line. The displacement time graph must be a straight line. So look at this. You see here AB is what? It's a straight line. Similarly CD is what? Straight line. Okay, so in AB as well as CD parts, right, what is the curve? It is a straight line. So AB is what? It is the A. CD is what? That is the C. Both in A and C cases, what is it? It is a straight line, means what? Velocity will be constant. Velocity constant means in that particular part of the curve, the acceleration is going to be 0. Okay, we'll go on to the next question. The figure shows velocity time graph of a particle which is moving along the straight line. So all this, we are looking at the particles moving along a straight line, 1D motion. Identify the correct statement. So if you see here, right, the velocity is starting from 10 meter per second. It is a straight line with a negative slope, means what? This is in deceleration. Clearly what we can say, it is in deceleration, which is what? The acceleration will be negative. So what will be the acceleration value? Negative. Okay, so we have to look at these options and conclude. Option A is what? The particle starts from origin. See, when the velocity time graph is given, we cannot say where it is starting, right? That we cannot say. By looking at the velocity time graph, what is the starting position of the particle, we cannot say. So this obviously we will not be able to comment. Option B is what? The particle crosses the initial position at t is equal to 2 seconds. See, where is t is equal to 2? It is here. The corresponding marking on the velocity graph is what? -10. So if you see the area between the velocity curve and time axis, what is the area between the velocity curve and time axis? This is the area, right? So from t is equal to 0 to t is equal to 1, we see this is what? Positive area. T is equal to 1 to t is equal to 2, identical but negative area. So overall area means what? It will be 0. What is the area going to represent? It is going to represent, what is the area going to represent? It will represent the overall displacement, right? So the area between the velocity time curve and the x-axis represents what? X-axis means time axis. It represents what? The displacement, overall displacement. So from t is equal to 0 to t is equal to 2, the overall displacement is 0, which means what? Maybe initially it is moving in one direction, then it is coming back, so that it is basically crossing that initial position. Overall displacement 0 means what? For some time they have a positive displacement, means it is going in, let us say, positive x-axis. Then the displacement is coming negative from t is equal to 1 to t is equal to 2, means what? The particle must be moving in the negative x-axis direction. So overall for the 2 second journey, right, the overall displacement is what? 0, which means the particle must be crossing the initial position at that particular time. So what is the answer for this? Option 2. Option C is what? The average speed of the particle in the interval 0 to 2 seconds is 0. See, average speed can never be 0. Average speed can never be 0, right? Because there is a motion. Average speed means what? Total distance by total time taken, right? That can never be 0. During the journey, if there is a change in direction means maybe overall displacement sometimes can become 0, right? Thereby we can have the average velocity might become 0, but average speed in this case will not become equal to 0. So here one thing we need to understand, when we look at the area, right, this area is coming as what? A positive when we talk about the displacement S1. So for the second part we will take the S2 to be what? Negative. But when we want to measure the distance, total distance covered means we will add S1 to the modulus of S2. Means look at this now, if this is going say in one direction, it is traveling for 5 meters and then it is coming back 5 meters. So the right side we take it positive, displacement means, left side we take negative. So thereby the overall displacement is what? Overall displacement will be 0. Okay, how I am saying plus 5 minus 5, look at this now. What is the area of the triangle? So the triangle area is what? Half into base into height only, no? That is what? Half into 10 into 1, that is 5. So this is what? 5 and this is minus 5, correct? So overall displacement means 0. But when you talk about the distance covered, what you will say? It is traveling for 5 meters. Then again it is traveling for 5 meters. So when you say distance means we will take only the modulus value. Okay, so for the velocity time graph, when you take the areas along with that sign below the x-axis means area is negative, right? When you take them along with the sign, we are including the displacements. But if you just take the absolute value or the modulus, then by adding them we will get what? Distance. So you can see clearly what is the distance going to be? 5 meters plus 5 meters, that is what? 10 meters. So overall distance will be there, so average speed cannot be 0. Okay, option D is saying all of them are correct. So all of them are not correct, right? Only the option B part is correct. Okay, next we have another graph. A particle is moving along the x-axis. Its x coordinate versus time graph is given. Using this data we have to plot the velocity time graph. So we have to look at the position time graph and we have to plot the velocity time graph. See, whenever we have to plot one graph from a given graph, right, always we need to keep one thing in mind. The graph will be demarcated at whatever the time values that are given here. So marked times are what? Look at this, 0, then 4, then 6. So accordingly we have to mark the values on the velocity time graph also. Okay, so from t is equal to 0 to t is equal to 4, so we will just mark these regions. What is this? Position is constant, right? Means velocity will be 0 straight away. This part, position is constant, means velocity will be 0, right? Then from 4 to 6, like that we have to first, because while practicing it, right, initially we will do like this only. Then once we get some comfort, we will be able to write it. Then from 4 to 6, this is the part. It is a straight line with a negative slope. The slope of that line will be what? The velocity rate. So what will be the slope of the line? Look at this. This point is 4, 4. And what is this point? 6, 0. Okay, so what is the slope? Means it will be what? y2 minus y1 by x2 minus x1. So what is it? Minus 4 by 2. That is minus 2. So velocity will be what? Minus 2 meter per second. So like this we have to get the values for different parts of the graph. Once we have the values means then we will be able to conclude it. Okay, so let us see what will happen next. From 6 to 10. So we covered up to 0 to 4 is over, then 4 to 6 is over, now 6 to 10. So here look at this. This is continuing in the same straight line, right? Means 6 to 10 also it will be what? The velocity will be same, minus 2 meter per second, that will not change. Then from 10 to 14, look at this. This is a straight line with a positive slope. Okay, so see here what is happening. This point is what? 14, 0. This point is what? 10, minus 8. So what is the relation? y2 minus y1, 0 minus of minus 8 divided by x2 minus x1, 14 minus 10, that is what? 8 by 4, that is 2. So velocity in this case is what? Plus 2. So using this we will be able to draw the plot. Look at this, 0 to 4. It is what? 0. Then 4 to 10. 4 to 6 also same. 6 to 10 also same. 4 to 10 straight away it is what? Minus 2. Horizontal line. Then 10 to 14 it will be again constant. It will be what? Plus 2. Okay. So 0 to 4 it is what? 0. 4 to 10 it is what? Minus 2. And 10 to 14 it is what? Plus 2. So that is how we will be able to draw the graph of the velocity time graph from the position time. So the approach is very similar, like in other cases also. If you are having a different graph given, using that you have to draw some other graph. Always the same approach. What is it? First we have to break the graph for whatever the time limits that are given, and then we'll have to calculate for the, in this case we have divided the time into whatever the limits they have given. Then for these time limits we are calculating what is the velocity value. Then we will be able to plot the graph. Look at this, velocity time graph of a particle moving along a straight line is given. In the time interval 0 to 14, so 0 is here and 14 is here. From 0 to 14, find the average velocity. Average velocity means what? Total displacement by the time taken. So total displacement means what? The area that is enclosed between the velocity curve and the x-axis or the time axis. You see here one thing, the area above will be positive, area below will be negative. That part we are clear. Okay. So here look at this. Now we will divide this area into different segments. Let us call it as part 1. It's a triangle. What is the area? Half into base is 4, height is what? 20. That is 40 meters. Part 1. Okay, so that is the, you can say, displacement 1. Then look at this. No, this second part. It is kind of the rectangular part. What is the area of the rectangle? The width is 2 and height is 20. What is it? 2 into 20? 40. So S2 will be what? That is also 40. Okay, so we got S1, S2. Now you look at this one, right? The third part. Third part is what? That is another triangle. So base is what? 4. Height is 20. So S3 will be what? Half into 4 into 20. That is S3 is also what? 40. Now we're done with S1, S2, S3. What is the next one? The area that is below. Look at this. So area below means that is our S4. What is it? Half into, that is like a triangle, right? Base is what? 10 to 14 means that is 4. Into height, we will take the negative value, right? That is where the area becomes negative. What is the height here? We have to take minus 10. That's how the area becomes negative, and that is why the displacement also will be negative. So look at this now. What is it? 2. So what is it? Minus 20 meter. So how much do we have? The overall displacement means what? S1 plus S2 plus S3 plus S4. That is the overall displacement, right? So 3 40s are there. That is 120. Minus 20 means that will be 100 meters. That is our overall displacement. What is the time? The time is 14 seconds, right? So the average velocity, what is it? Overall displacement 100 meters divided by 14 seconds. So we can see some cancellation. What is it? We can say 50 by 7 meter per second. Like that we can leave it. Otherwise we can even simplify. 50 by 7 means what? That is like 7 point something. Okay, because 7 sevens are 49, right? So this is another question model where we'll have the area, that area below the x-axis is negative, right? That point is being checked upon. Okay. Next we have another interesting question. The lift is starting from rest. Starting from rest means what? Its initial velocity is 0. Its acceleration is plotted against the time. Means they are giving us the acceleration function with respect to time. When it is coming to rest, after some time it is again coming to rest. Okay, its height above the starting point. So you see what is happening for some part of the journey, which is 0 to 4 seconds, it is in uniform acceleration. Then acceleration is 0. means whatever the velocity it is having, it will continue with the same velocity, uniform velocity motion. Then retardation, the motion is identical, right? So finally it will again come to rest. So they are asking us what is the height. So it is starting from here, it is going up. So what is the total height? Means we have to calculate S1, same, S2, S3. Three parts of journey are there: acceleration, uniform velocity, retardation. First part, right, starting from rest means initial velocity 0. What about the displacement formula? Ut plus half at square, right? Means what is it? U is anyway 0, half into A is what? Acceleration is 2 into t square. T is what? 4. So 4 square. What is it? 16 meters. Straight away we are able to get it. What is the value? 16 meters. S2, second part, it is uniform velocity, but we need to know what is the velocity, right? How do we get it? Look at the area, right? So from 0 to 4, what is the area? The area between the acceleration curve and the time axis is what? 2 into 4, that is 8. So 8 meter per second is the area. That is what? Change in velocity, means final velocity minus initial velocity. Initial is 0, right? Starting from rest. So after 4 seconds, what is the velocity? It will be what? 8 meter per second. Which means second journey, right? This is like a consecutive motion. First part of the journey, final velocity will be the initial velocity of the second part of the journey. Means whatever is the final velocity here, that is 8 meter per second, will be the velocity for the second part. Second part is anyway uniform velocity, right? So second part of the journey, velocity is what? 8 meter per second. For how much time it is happening? 4 seconds to 8 seconds, means that is 4 seconds. So what is it? 32 meters. That is the displacement in the second part of the journey. Okay. Now we will go to the third part of the journey. So third part of the journey, what we need to see here? It is a case of the deceleration. Third part of the journey is what? It is a case of the deceleration, right? So now we will see that in that case, again we will use the equation of motion only. We can use the equation of motion. So what is it? The velocity in the second part is constant, 8 meter per second. That will be the starting velocity. Third part also starting. So what is it? 8 into time is 4, because third part is continuing from 8 seconds to 12 seconds, right? 8 into 4 ut plus half into acceleration is what? Minus 2 into t square. So you see here what is happening? 8 4s are 32 minus 16, that is 16 meters. So S1 is what? 16. S2 is what? 32. S3 is another 16. So overall displacement, that is the height to which it is raising above the starting point, right? What is it? 16 plus 32 plus 16 means what is it totally? It is 64 meters. Check it. What is the height to which it is raising above the starting point? It is what? 64 meters. Okay. So this is another question model which we can have. Okay. Next, we are done with the discussion on the sample questions. We will just try to summarize, okay, our analysis on that graphs, particularly the velocity time graph and the position time or the displacement time graph. Okay. So from the acceleration time graph, we will only be able to calculate what is the change in velocity. So if you look at these two graphs, right, we can do, in fact, particularly this one, velocity time graph, area between the velocity curve and the x-axis also has got significance. Slope also has got significance. Okay, so we'll see. Here we are marking different regions. Okay, so the first part of the graph, right, both the velocity time curve as well as the displacement time curve, they are corresponding to same type of motion. Okay, so first part of the A part, what is A part? Velocity time is a straight line, means what? Straight line with a positive slope. This is an accelerated in the positive direction. So velocity will be what? It will be positive. You can see velocity is what? Positive, and it is increasing. How are we saying velocity is positive? Because it is above the x-axis, right? So velocity is positive and it is increasing. Okay. Look at this. Since we have an acceleration motion, remember we already talked about it. In case of acceleration motion, right, the position time or the displacement time curve will be what? It will be concave up. You see here, what is it? This part, right? What is this part? This is the concave up part. Then the second part of the journey, the part we are marking as U. U is what? it is a constant velocity. We can say it is a uniform velocity, but still it is moving in the positive direction because velocity is positive. So here the velocity value will be constant. How would we represent this in terms of the displacement time graph? It will be a straight line. It will be a straight line with a positive slope, okay, because it will be making an acute angle. You can see here the u part will be what, because the slope of this straight line will be what, that constant velocity, it must be positive. That is the reason why here the angle will be what, it will be an acute angle. Okay, now we will come to the part R. What is this part R? The part R is basically the part where we are having the velocity decreasing at a constant rate. Means what, this is the retardation. Retardation is there, but still the particle is moving in the positive direction. Why? Because velocity is positive. We can see, okay, the velocity is positive but it is decreasing. You see here on the displacement time graph how it will be concave down. When it is retardation means concave down. This will continue in the other side also. We'll see in the other side, right? We are calling it as inverse, means it will be just inverse. Other side A inverse, right? It will be continuation, retardation continuation, okay. So it will be what, once the velocity comes to 0 at this point, it still continue to have the acceleration in the opposite direction. Okay, so what is it? It will be having an acceleration in the opposite direction or the negative direction. So here you see in the A inverse part, right, the velocity is becoming negative, but it is increasing. In the negative direction it is actually what, increasing. Okay, so once the velocity becomes 0, right, so where is it becoming 0? It is becoming 0 when it is passing through that x-axis. This is the point where it is becoming 0, where we ended the part R, the retardation beginning. Now we are in the, so this is where the velocity is 0. So we can see here on the displacement time curve also, it will be what, if you draw a tangent means it will be what, horizontal line. So slope is what is the slope here? Slope is 0, right? After that we are having the inverse part. We can see inverse, it is a acceleration in the negative direction. So velocity will be increasing but in the negative side. Then again we have u inverse. It will be just the inverse of uniform velocity. But why are we calling it as inverse? Because it is in the negative side, that's it. So u inverse means what? It's a uniform velocity motion but in the negative direction. Okay, so velocity will be what? It will be negative and constant. We can see here, you can see from the displacement time graph, what is the slope here? It is a straight line which is making an obtuse angle with the x-axis. So this is the x-axis, means it is making an obtuse angle. Theta will be what? It will be an obtuse angle. So here the slope will be what? It will be negative slope. Okay, the last part is the R inverse. So now after this moving in the negative direction, we are giving it a acceleration in the positive direction. We can see here. So the velocity is negative, but you see the slope of the velocity time graph, what is it? It is what? Acute, means it is now having a acceleration. The R inverse part is what? Acceleration. But you see it's like this, the velocity is in the negative direction, we are giving an acceleration in the positive. So what is it? The motion will be retarded in the negative sense, means velocity is initially negative, right? We are giving an acceleration in the positive, so the velocity will keep on decreasing till it becomes 0. The velocity will keep on decreasing till it becomes 0. So we can see here what is the corresponding graph here. It will be what? Whenever the acceleration is positive, right? What is it? It will be concave up. Okay, so it will be what? Always concave up whenever the acceleration is positive. So this is how we will be able to analyze the graph of the velocity time function and displacement time function under varying scenarios. So broadly we are able to cover all the scenarios that we discussed so far, right? So this is what we need to discuss in terms of the graphical analysis. What you can do is you can keep practicing some questions, because the more we practice, that much more comfortable we'll be able to feel in terms of the graph analysis questions. Okay, so they will not be that difficult. The only thing is we need to make sure that we don't commit any unwanted errors while solving problems based on the graph analysis. Okay, we'll see in the next video.